Composition of functions is really important. Okay, so if this is f and this is g, so f of g means put g inside everywhere there's an x in f. So this would be f is the outside framework. I'd put cosine in for the x plus 3. G of f of x is not quite the opposite, but it's different. So I'm going to take the framework of cosine, and whenever there's an x, I'm going to put in what f of x is. Okay, the same thing here. F of g of x is tangent, and I'm putting in the 1 over x squared where there's an x. G of f of x, I'm going to have 1 over, and where there's an x, I'm going to put in the tangent of x. So this, let's make sure we all are on the same page, we know is this. We're going to need to know that those are equivalent. Okay, f of g, I'm going to be putting in the cube root into the square plus 1. And you know this power over root, that's the same thing as saying to the 2/3 power. G of f, so I'm taking the cube root of, and then I'm going to put this inside, and that's as simplified as that gets. F of g, so I'm going to take ln of sine of x, and g of f, I'm going to have sine of ln of x. So it's not necessary, but you could put parentheses. That's inside the ln, and that's inside the sine function. Okay, so you making up your own functions is going to be necessary. So if that's capital F, your little f, the outside function, would be e to the x, and your g of x would be 5x squared. This one here, the outside function would be 1 over x, and the inside function would be x cubed plus 4. Here, the outside function would be x squared, and the inside function would be secant of x. Here, the outside function is cotangent, and here the inside function is root x. Okay, so sometimes you have to do several layers. So f, g, and h, and can't use any of them be the simple case of y equal x. So f and g and h. So I see that the f of x would be the ln. Then the next one would be 1 over x. And then the h would be x plus e. All right, so this one here, the most outside function I see happening is the cubed. And then the g would be the cosecant. And then the h would be e to the x. Here, the most outside function is the cotangent. Then the next inside function would be ln of x. And then the next inside function would be pi x. All right, so the difference quotient we're going to learn is important. So this is f of x, and so then you know f of x plus h will be putting in an x plus h everywhere there's an x. So it would be this. So I'm going to put this in for right there. So I have x plus h squared minus 3, and then I'm going to subtract off an f of x, which is x squared minus 3, and that's all over h. So this is necessary to multiply out, and then make sure you distribute this negative sign. So I get x squared plus 2xh plus h squared minus 3 minus x squared plus 3. Being careful with that distributing. So I see the x squareds go away. I see the 3's go away. So what's left? 2xh plus h squared all over h. So be careful how you cancel. You want to factor the h out to get 2x plus h over this h. Now they cancel, so you get 2x plus h. So be really careful with the canceling. Let's do this one last one here. So a little bit of a different function, same idea. So I'm going to put square brackets around f of x plus h. So it's 3x plus h squared plus x plus h, right? Putting in x plus h everywhere there's an x. Subtract off f of x. And that's all over h. Okay, so let's multiply this out. So I'm going to have the 3x squared plus 2xh plus h squared, and this will give me a plus x plus h minus 3x squared minus x all over h. So I have a little bit canceling, right? The two x's go away, and I'm going to take the time to multiply this 3 in. 3x squared plus 6xh plus 3h squared, and then I have a plus h minus 3x squared all over h. So the 3x squares go away, and then I'm going to factor an h out. So I get 6x plus 3h plus 1 all over the h. The h's cancel, so I get 6x plus 3h plus 1.